polygon given the length of its side. Let the number of sides of the polygon be 7, that is heptagon. Method 1. Draw a line AB equal to the given length. With center A and radius AB, draw a semicircle BP. With a divider, divide the semicircle into 7 equal parts, same as the number of sides. Number the division points as 1, 2, etc. starting from P. Draw a line joining A with the second division point 2. Inscribe circle method. Draw perpendicular bisectors of A2 and AB intersecting each other at O. With center O and radius OA, describe a circle. With radius AB and starting from B, cut the circle at points C, D, etc. up to 2. Draw lines BC, CD, etc., thus completing the required heptagon. Arc method. With center B and radius AB, draw an arc cutting the line A6 produced at C. With center C and the same radius, draw an arc cutting the line A5 produced at D. Find points E and F in the same manner. Draw lines BC, CD, etc. and complete the heptagon. Method 2. General method for drawing any polygon. Draw a line AB equal to the given length. At B, draw a line BP perpendicular and equal to AB. Draw a line joining A with P. With center B and radius AB, draw the quadrant AP. Draw the perpendicular bisector of AB to intersect the straight line AP in 4 and the arc AP in 6. A square of a side equal to AB can be inscribed in the circle drawn with center 4 and radius A4. A regular hexagon of a side equal to AB can be inscribed in the circle drawn with center 6 and radius A6. The midpoint 5 of the line 4, 6 is the center of the circle of the radius A5, in which a regular pentagon of side equal to AB can be inscribed. To locate center 7 for the regular heptagon of side AB, step off a division 6, 7 equal to the division 5, 6. With center 7 and radius equal to A7, draw a circle. Starting from B, cut it in 7 equal divisions with radius equal to AB. Draw lines BC, CD, etc. and complete the heptagon. Regular polygons of any number of sides can be drawn by this method. Now let's draw a pentagon. First we'll draw a line AB. Draw a circle with center as A and radius as AB. Similarly, draw one more circle with center as B and the radius as AB, cutting the circle 1 at C and D. Next, draw an arc with center as C and radius as AB. The arc cuts the circle 1 and circle 2 at E and F respectively. Then, draw a perpendicular bisector of line AB which cuts the arc EF at point G. Draw line EG long enough to cut the circle 2 at point P. Similarly, line FG is extended to cut the circle 1 at point R. After that, with P and R as centers and AB as radius, draw two arcs intersecting each other at point Q. Finally, let's draw lines connecting these points to complete the pentagon. Let's study a simple method for constructing a regular octagon. The method involves inscribing a regular octagon in a given square. Consider the given square ABCD. Now we'll draw the diagonals AC and BD intersecting each other at O. Then, with A as center and AO as radius, draw an arc cutting edges AB and AD at point 2 and 7 respectively. Similarly, with centers as B, C and D and radius as AO, draw arcs to obtain remaining points. At last, we'll join the points 2, 3, 4, 5, 6, 7 and 8, 1, thus completing the octagon. General method of construction of an ellipse. Problem 6.1. To construct an ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity is 2/3. Draw any vertical line AB as directrix. At any point C on it, draw the axis perpendicular to the AB directrix. Mark a focus F on the axis such that CF equals 50 mm. Divide CF into 5 equal divisions. Sum of numerator and denominator of the eccentricity. Mark the vertex V on the third division point from C. Thus, eccentricity E is equal to VF upon VC equals to 2/3. Let us now construct a scale on the axis which will directly give the distances in the required ratio. So, at V, draw a perpendicular VE equal to VF. Draw a line joining C and E. Thus, in triangle CVE, VE upon VC equals VF upon VC equals 2/3. Mark any point 1 on the axis and through it draw a perpendicular to meet CE produced at 1 dash. With center F and radius equal to 1, 1 dash, draw arcs to intersect the perpendicular through 1 at points P1 and P-1. These are the points on the ellipse because the distance of P1 from AB is equal to C1. P1F equals 1, 1 dash and 1, 1 dash upon C1 equals VF upon VC equals 2/3. Similarly, mark points 2, 3, etc. on the axis and obtain points P2 and P-2, P3 and P-3, etc. Draw the ellipse through these points. It is a closed curve having two foci and two directrices. Concentric circles method to draw an ellipse. Draw the major axis AB and the minor axis CD intersecting each other at O. With center O and diameters AB and CD respectively, draw two circles. Divide the major axis circle into a number of equal divisions, say 12, and mark points 1, 2, etc. as shown in the figure. Draw lines joining these points with the center O and cutting the minor axis circle at points 1 dash, 2 dash, etc. Through the point 1 on the major axis circle, draw a line parallel to CD, the minor axis. Through point 1 dash on the minor axis circle, draw a line parallel to AB, the major axis. The point P1 where these two lines intersect is on the required ellipse. Repeat the construction through all the points. Draw the ellipse through A, P1, P2, etc. Problem 6.8. To construct a parabola when the distance of the focus from the directrix is 50 mm. Draw the directrix AB and the axis CD. Mark focus F on CD 50 mm from C. Bisect CF in V the vertex because eccentricity equals 1. Mark a number of points 1, 2, 3, etc. on the axis and through them draw perpendiculars to it. With center F and radius equal to C1, draw arcs cutting the perpendicular through 1 at P1 and P-1. Similarly, locate points P2 and P-2, P3 and P-3, etc. on both the sides of the axis. Draw a smooth curve through these points. This curve is the required parabola. It is an open curve. Problem 7.6. In a slider crank mechanism, the connecting rod AB is 750 mm long and the crank OA is 150 mm long. The end B moves along a straight line passing through O. Trace the locus of a point P 300 mm from A along the rod for one revolution of OA. The slider crank mechanism. This mechanism is explained as follows. The end A of the connecting rod AB is connected to the crank OA, which rotates about O. The other end B is attached to a slider which slides along a straight line. The locus of A will be a circle and that of the end B will be a straight line. The locus of any other point, say P, on the connecting rod will be neither a circle nor a straight line and can be determined by the following steps. 1. By assuming various positions of the crank end A. 2. By obtaining the corresponding positions of the end B. And 3. By locating the position of P on the lines joining the first two positions. Finally, a smooth curve drawn through the located points will be the locus of P. The curve obtained is known as coupler curves. Let's see the stepwise procedure to draw the above path. First, draw a circle which is the path of point A. Then, divide circle into 12 equal parts. From the center of the circle O, draw center line which passes the end point B of the rod. With center 1 and radius AB, cut the path of B at point B1. Draw a line joining 1 and B1. Here, we have to trace the locus of the point P on the rod at a distance from point A. Now, again with center 1 and radius PA, cut the line 1B1 at point P1. Obtain other point in similar manner. Then, draw a smooth curve through these points. This curve is the locus of point P. Observe that the distance B1, B7 is the travel of the slider and is equal to twice the length of the crank. This length is known as stroke length. Note the movement of slider is not uniform with that of the crank end A. This completes the procedure to obtain the required locus of any given point using slider crank mechanism. Problem 7.7. In the offset crank mechanism, the slider end B moves in guides along the line CD, 225 mm below the axis O of the crankshaft. Plot the locus of a point P 450 mm from A along AB and of a point Q along the extension of the rod 300 mm beyond B. Determine also the travel of the slider. In this example, we shall discuss the other type of mechanism, which is offset crank mechanism. The initial procedure is same like the above example. First, divide the path of A, that is circle, into 12 equal parts. Then obtain the positions of the end B on its path. Similarly, obtain the positions of point P as shown in the above example. Here we can trace the locus of the point P. Now, offset the point B downwards from its original position. Now draw the center line CD from this point of offset. Now draw lines 1B, 2B, so on up to 12B and mark positions Q1, Q2 up to Q12. It is also necessary to determine the limiting position of the end B. These are found by drawing arcs with center O. Radii AB minus AO and AB plus AO and cutting the path of B at point B dash and B double dash. Then draw B dash O and extend it further, which gives point Q dash. Similarly, draw B double dash O to obtain the point Q double dash. These are the limiting positions of point Q. Joining the points obtained gives the path that is the locus of point Q. Now extend the line B dash O to obtain A dash and B double dash O to obtain A double dash. These are the limiting positions of end A. A dash and A double dash will be on the lines B dash O produced and O double dash respectively. Observe that the travel of the slider is shown by the distance B double dash B dash. So friends, in this session we learn the simple slider crank mechanism. Problem 7.12. The end A of a rod AB rotates about O while the end B slides along a straight line. A crank CQ oscillates about Q. Draw the locus of the midpoint P of the connecting link CD for one revolution of the crank OA. AB equals 1500 mm, CD equals 750 mm, OA equals 450 mm and CQ equals 1200 mm. Divide the circle in 12 equal parts and number the parts. Extend the center line 1O such that it passes through the end B of the rod. Then draw lines of size equal to AB from all 12 points of the circle up to line OB. We will determine the various positions of point D as follows. Point D from the end A. Now take the same distance from point 1 on the circle and mark point D1 on the line 1O. Similarly, mark point D2 to D12 on their respective lines. The point Q from the extended line passing through the end B. Observe that the distance CQ is given. To determine the path of point C, draw an arc with radius and taking center as Q. Now, with centers D1, D2, etc. and radius CD equals, draw arcs cutting the above path of C at points C1, C2, etc. Next, locate the midpoints of lines D1, C1, D2, C2, etc. and call them as D1, D2, etc. The required locus of the midpoint P is obtained by drawing a curve through these midpoints. Thus, we can determine the locus of a midpoint of a link in the 4-bar mechanism.